Hello, welcome. In this short video, let us look at an example illustrating the Bayes rule. Example on Bayes rule. Consider the following problem. A customer goes to a car store and buys a car. So, a customer buys a car. And we are given the following prior properties, that is, this car is made in one of the following 4 plants with the following prior properties: plant number and prior probability corresponding to each of the plants. For plant 1, the probability is 0.2, and for plant 2 it is 0.24, for plant 3 it is 0.25, and plant 4 it is 0.31. So given this prior probability information, we want to find the posterior probabilities corresponding to each plant under when a claim is made, and also for the case when a claim is not made. So now let us look at the posterior probabilities. So specifically, we are going to look at how to use the Bayes rule to determine these posterior probabilities. So for example, if a claim is made, that is the corresponding plant numbers, a claim is made then we are interested in the probabilities of the plants given this claim. So the question is, if the claim is made, then how does the probabilities, or how do the probabilities corresponding to each plant change? That is, given the following information: plant number and likelihood probability. That is the probability of a claim given this plant number. That is likelihood basically stands for the probability of the claim given the particular plant. That is, if the car is from plant 1, then the corresponding likelihood is 0.05. That is, likelihood or the probability of the claim given plant 1. And similarly, for plant 2, it is 0.11, and for plant 3, it is 0.03. And if the car is from plant 4, the likelihood is 0.08. So given this information, how do we revise the probabilities corresponding to each plant? That is, for example, for plant 1, the posterior probability of that the car is from plant 1 given the claim is made is equal to the prior probability of plant 1 multiplied by the probability of claim given plant 1, that is the likelihood probability corresponding to plant 1, and then the total claim probability, that is the total probability of making a claim. So the first value, that is probability of plant 1, is given in this table. That is probability of plant 1, the prior probability of plant 1 is 0.2. That is without any claim information. The probability that this car comes from plant 1 is 0.2. So we know the prior information. That is prior probability of plant 1 is 0.2. And then the probability of the claim given plant 1, it is the likelihood information, is from this table it is 0.05. Now we need to know the denominator, which is probability of a claim, that is probability of making a claim, which is basically the sum of products of the probabilities of claim given plant information, that is the likelihoods, multiplied by the priors. Excuse me, this is plant I. So when you add all these products, you should get the evidence, that is probability of making a claim. So this is the likelihood and this is evidence. And this sum of the products can be easily calculated because we know all the information we need for this sum, which is basically the products of the values from this table with the priors from this table. So which should be equal to 0.2 into 0.05 plus 0.24, that is probability of plant 2 multiplied by probability of claim given plant 2, which is 0.11 from this table, and by simply using all other values, this should be equal to 0.25 into 0.3 plus 0.31 into 0.08, and the sum should be equal to 0.0687. Now we know all the values that are needed for calculating this ratio. So the probability of plant 1 given a claim is equal to the product of the prior, which is 0.2, multiplied by the likelihood, which is 0.05, divided by the evidence, which is 0.0687. So the answer should be equal to 0.14. That's the probability of plant 1, that the car comes from the plant 1 given a claim, given the information that a claim is made. Similarly, we can calculate the probability of plant 2 given the information on the claim, that is given a claim is made, it should be equal to 0.384. Similarly, the probability of plant 3, that is the probability that the car comes from plant 3 given the information that a claim is made, is equal to 0.109. And finally, probability that the car comes from plant 4 given in the information that a claim is made should be equal to 0.361. All these values can be calculated by using a similar logic as in this first ratio. Now let us look at calculating the posteriors when a claim is not made. That is, we want to find the information probability of plant I given no claim is made, that is no claim, is equal to the product, this the prior of the plant I multiplied by the likelihood of no claim given plant 1, this plant I, divided by probability of no claim, that is the evidence that there is no claim, which should be equal to 1 minus probability of a claim. Similarly, here probability of no claim given plant I should be equal to 1 minus probability of a claim given plant I, that is probability of no claim given plant I is equal to 1 minus probability of a claim given plant I. Similarly, probability of no claim is equal to 1 minus probability of a claim. That is the evidence from the first part of the problem, which is clearly equal to 0.0687. So this value should be equal to 1 minus 0.0687, which is 0.9313. So we have the denominator for the posterior probability, and we also know the prior probabilities, and the numerator and the second term in the numerator is basically 1 minus the values in the table 2, that is 1 minus the values in this table. So for the first plant, that is probability of plant 1 given no claim, that is given the information that the claim is not made, is equal to probability of plant 1 multiplied by 1 minus probability of a claim given plant 1 divided by probability of no claim. So the first value is clearly equal to 0.2 from the table 1. The first value is 0.2, and the second one is 1 minus 0.05, that is the second value in the numerator is 1 minus 0.05, and the denominator is clearly equal to 0.9313, is 0.9313. So this should be equal to 0.203. 4. Now by following a similar logic, we can calculate the probabilities of plant 2 given the information that a claim is not made. This probability of plant 2 given no claim is equal to 0.224, and probability of plant 3 given no claim is equal to 0.261. Again, by following the same logic, that is, this posterior probability is equal to the product of the prior, that is probability of plant 3, multiplied by the likelihood, that is probability of no claim given plant 3, and divided by the probability of no claim, that is 1 minus the evidence of a claim. So using that formula, this value should be equal to 0.261. And finally, probability of plant 4 given no claim should be equal to 0.306. Now let us tabulate the final results and look at the possible conclusions. That is, given the prior probabilities as 0.2 for plant 1 and 0.24 for plant 2 and 0.25 for plant 3 and 0.31 for plant 4. And then posteriors, when a claim is made, the values are 0.146, 0.384 and 0.109 and 0.301. And when no claim is made, that is, when a claim is not made, then the posterior probabilities are 0.209, 0.229, 0.261 and 0.306. Clearly, when a claim is made, the values of the probabilities corresponding to each plant change drastically compared to the posteriors when a claim is not made. This is because a claim is basically a rare event. When a rare event occurs, the probabilities are changed drastically, and when no claim is made, that is a common event which is more probable, so the probabilities corresponding to each plant do not change by much. So in this case, we can clearly see that the Bayes rule revises the probabilities. Thus, this is a good example illustrating how information from observations, that is claims or no claims, can change the prior beliefs. Specifically, when the occurrence is rare, there is a drastic change in the prior probabilities or prior beliefs, and when the occurrence is common, like no claim, the change is rather minimal. Thanks for watching.